Okay, welcome. And so today we are going to do another example of finding the surface area of the area of revolution of a graph. And this time we're going to go around the y-axis. Okay, so if you look at this example here, we have this function, but it's a function of x. We'll have to deal with that. And here's our interval for all y from 0 to 2, and we're going to find the surface area of the area of revolution around the y-axis. So the first thing we need to do is we need to write this as a function of y. So I'm going to solve for x. And when you solve for x, you get y cubed over 3. Or oops. Okay. And so this is a non-negative curve over the interval. So it's a non-negative function, smooth. So we can do this. So let's do it. So let's start with the function. I'm going to start over here. So we've got surface area, and since we're revolving around the y-axis, we need to use the one that says c of d. So c to d, the integral from c to d of 2 pi and g of y times the square root of 1 plus g prime of y squared dy. Okay, that's the formula that they gave us, right? Now, let's plug in the information. So we're going from 0 to 2 in the y direction. And then 2 pi, I'm going to pull that out again. So 2 pi, it's a constant. And then g of y is 1/3 y cubed. But I'm going to pull the 1/3 out because it's also a constant. Now, what is g prime of y? Well, let's find out. So g prime of y, again, what do? You take the derivative, right? So that's going to drop the 3 down. It's going to cancel with 3, and I get y squared. So now I'm going to add the last piece, which is going to be 1 plus the quantity y squared, quantity squared dy. Okay? So far so good. So now at this point it's just a matter of simplifying. And again, I haven't drawn a picture, but again, if you want to draw a picture to get an idea what it looks like, that's fine, but you don't necessarily have to. If you know what you're doing and you realize that you've got a function, sometimes you will need to look at the graph. Okay, so let's see, let's go on. Okay, let's simplify this further. So 0 to 2, and y cubed, 1 plus y to the 4th dy. Okay, now I'm going to do a u substitution because it's obvious that I'm going to do u substitution, and I can do it because I've got a y to the 4th here, and I've got a y to the 3rd outside. So, and this is a constant, so I can make this whole thing u, and then the derivative of this thing is going to give me y cubed. So I can match the y cubed with the dy, and here we go. Let's do that. So I'm going to make u to 1 plus y to the 4th du will equal 4 y to the third dy. And of course, I'm going to divide both sides by 4. So I get 1/4. And so now I'm going to rewrite my integral. So the limits of integration, so if it's 0, if y is 0, I get 1. If y is 2, I get 17. Right? So this is going to go from 1 to 17. And now I'm going to put in, oh, wait a minute. Dropped my, hold on. Dropped my 2/3 pi. So this is going to be okay, so now when I do my u substitution, this is going to be the square root of u, and then I'm going to get a 1/4 du, and so I'm going to pull out the 1/4, and so over here I'm going to get the square root of u du again. Okay? And now, let's simplify this. So this is going to become pi over 6. So I get pi over 6 times 2/3 u to the 3/2 from 1 to 17. Okay? And now I'm going to now evaluate. Okay, so I can pull the 2/3 out. So that's going to give me what? Pull the 2/3 out, it's going to give me this cancels with this, and that gives me 3. And so that's going to give me pi over 9. So I get pi over 9, and I go from 17 to the 3/2 minus 1 to the 3/2, which gives me pi over 9 times, well, this is just going to be 1. This is going to be this is going to be 17 square root of 17 minus 1. And I believe we're done. Yeah, 17 to the 3/2. Yep, so this is it, we're done. That's the final answer. And I would leave it as an exact answer. Okay, now if you stick it in your calculator, you'll get approximately 24.118 square units, right? Surface area, so it's square units. But this is the exact answer. Okay, here's one for you to try out. Again, practice makes improvement. Okay, so in this example, g of y is 9 minus y squared. And the interval is going to be for all y in the interval 0 to 2. And they want to find the surface area of the surface generated by revolving the graph of g of y around the y-axis. Okay. Take care. I'll see you next time.